Rick Garrity, Executive Director of the Environmental Protection Commission of Hillsborough County. One of our main responsibilities here at EPC is to make sure the county's waters stay free of pollution and contaminants. Clean water in the Bay Area ensures a safe environment for aquatic wildlife and safe drinking water for your home. That's where the Water Management Division comes in. They make sure all new developments and existing businesses in the county have proper disposal methods for their wastewater. They accomplish this by granting permits to industrial and domestic facilities once the proper requirements are met. If you've ever wondered what happens to all that water once it leaves your home, stick around. We'll show you how the Water Management Division keeps a watchful eye on that wastewater. Down the drain is just the beginning of the story on this edition of Clean Living.
Water plays an important role in our daily life. It is used by utilities that generate our power, businesses that process our food, and construction companies that build our homes. From washing the dishes to watering the lawn, we rely on having clean and safe water at our disposal every single day. Water quenches our thirst, provides a soothing hot shower, and washes our clothes. But did you ever stop to think about what happens to that water once it goes down the drain? Where does it go as the underground is transported along? And how is it treated so it can be safely used? All of these things are concerns of the Water Management Division.
Our main thrust is to protect water quality in Hillsborough County. Our drinking water sources here in Hillsborough County come from either the Hillsborough River or groundwater. There's many sewage treatment plants and many industrial wastewater sources, all those with the potential to impact both surface and groundwater, hence our drinking water. So our regulatory program is geared towards ensuring that those discharges that go back into the environment are going to have a negligible impact on the water bodies in Hillsborough County, thus protecting our drinking water, which is obviously a major concern to our citizens.
This is accomplished by using a program that requires permits to be issued for any facility that discharges to county waters. The process has two sections, one for permitting and one for compliance.
Facilities that are expected to produce industrial wastewater that could be a source of pollution are required to have a permit. This permit is a management tool, if you will, for pollution. It's for pollution control. It dictates what kind of operation they should have, what kind of treatment system, how this wastewater is going to be contained, and ultimately how is it going to be disposed of without creating a nuisance or pollution for the public.
There are two different types of permits, domestic and industrial. Domestic permits are given to domestic wastewater treatment facilities and all sewage collection systems in the county. Industrial permits are issued to industrial wastewater treatment plants that discharge directly to surface or groundwaters. The definition for wastewater varies, depending on whether it comes from a home or an industrial operation.
Domestic wastewater is wastewater that's primarily generated from residential homes, commercial establishments, institutions, and similar facilities, and pretty much is commonly referred to as sanitary wastewater or sewage.
Industrial wastewater is any wastewater produced by industrial operations that excludes domestic waste, which is sewage. All kinds of businesses produce wastewater, from small businesses as small as a car wash to a big business as a power plant, and anything in between.
Both deal with treatment of wastewater to produce an effluent that meets state standards or limitations. Most know that effluent is not drinking water, but many don't realize it can carry disease and bacteria. The state of Florida determines exactly what is considered safe water for the public. As the state regulations change, so do the permit requirements.
The permitting process is a very dynamic process. And it's triggered basically by effluent limitations. If there's a change in effluent limitation, then there'll be a change in what is required by the permittee.
The domestic permitting process is supervised by engineers who study wastewater treatment plans to ensure they meet state rules for completeness. It can either be a fairly quick or lengthy process.
If it's a brand new facility, sometimes it takes between 6 months to a year, given the complexity of the installation itself. Since we are located on what's called a high groundwater table, the effluent disposal system becomes the most complicated part of domestic wastewater permitting. This is where once the wastewater is treated, the two byproducts as a result of that treatment are the solids and the water, which could be utilized either for irrigation or released to the environment.
The permitting process consists of filling out an application, which is a state form consisting of 11 pages, so it's pretty consistent throughout the state of Florida. Once that application is submitted, it is reviewed by the permit engineer, and then the permit is issued.
Granting permits becomes more complex as the size of the facility gets larger. Large power plants or chemical operations take longer to sort out all the details. When the situation merits, EPC's engineers and the applicants meet in person.
If we issue the permit, there is no dispute. If we propose to deny because the facility did not meet all the requirements of the permitting process, then there is an appeal process. And there is an interim process where we sit together, explain to them why we are not going to issue the permit or why we're denying the permit. They would come and address, if they want to, all these reasons for us not issuing the permit.
My biggest concern, Sam, was the size of the berm around the whole property and whether or not.
And as long as we explain ourselves properly, as long as we tell them exactly what is expected of them, then there is no problem. We come to a common goal. Facilities want to operate in compliance. Facilities want to be a good corporate citizens without polluting the environment.
Granting permits is only half of the responsibilities of the Water Management Division. There's also the compliance section, which monitors the operations of the wastewater treatment facility.
Facilities do get out of line sometimes, or they becomes a little bit more challenging to them to do what they were intended to do. That's our compliance section, and there is a great communication interaction between the two sections, since sometimes they introduce new ways or methods or technology to try to resolve compliance issues that would have to be substantiated by permitting engineers.
The compliance section conducts inspections at permitted facilities to check on a company's follow-through. Are they doing exactly what was specified in their permit?
We have an obligation to inspect wastewater facilities in Hillsborough County twice a year. That's our obligation through our agreement with the State Department of Environmental Protection. We try to do all of them twice a year, including those that are not delegated. Those are the larger facilities that discharge to surface waters or that belong to Hillsborough County government, which we are a part of.
The treatment of wastewater is a detailed process. Domestic Compliance Supervisor Byron Bartlett goes into the field to see firsthand if promised improvements are in place. Today he is on location at Rice Creek Mobile Home Park in Riverview. Their wastewater treatment plant disposes its final effluent to Rice Creek. The permit allows the plant to discharge directly to surface waters, but not before the wastewater is properly treated.
Wastewater is treated primarily by a biological process. In order to provide that treatment, the raw sewage is introduced into a tank of mixed liquor, which is where the bacteria that provide the treatment reside. The boiling action visible during periods of aeration is providing dissolved oxygen to the bacteria that provide the treatment. The final part of what's referred to as the secondary treatment process is clarification. That's where the mixed liquor from the tank that's under aeration comes in, and the settleable materials settle to the bottom, are returned back to the head of the plant, and clear supernatant, or clear water in this case, overflows what are called weirs, and from that point chlorine is added through a pipe dripping into the weir box at the end of the trough, and from there it goes out to the ponds. The green color on the top of the pond that is not actually vegetation that you can see, grasses and so forth, is duckweed. It's a very small plant, very tiny leaves that covers most waters that are very low in dissolved oxygen and relatively high in nutrients.
Today, Byron is conducting a follow-up visit to Rice Creek to verify corrections that have been made for a few minor problems.
Just about all the deficiencies had been corrected. A brand new flow meter has been put in. The flow meter is a fairly important part of the wastewater treatment plant because the permit and the design of the treatment plant is based on the volume of the wastewater coming in. There were a few other minor things such as vegetation maintenance, but most of all the things were relatively minor, and they have apparently all been taken care of.
Inspections are done twice a year at facilities that are permitted by either the EPC or the Department of Environmental Protection. The wastewater produced at this facility is piped into retention ponds. Today, Sam Ilrabi and engineering specialist Paula Noblet are checking out 2 ponds in particular.
Some of them hold wastewater, some of them hold storm water that have filled into old mine cuts. And what the facility was doing was they were treating some of the wastewater with lime, and then they were also treating some with a reverse osmosis unit. And then the water from the reverse osmosis unit was blending with the water that was treated with lime. And for further blending, then they were also blending in storm water from some of the mine cuts. And then that was ultimately being discharged. We're looking to make sure that the pond is adequately holding the water in the pond, that there's no signs of seepage, no signs that the dam or the perimeter of the pond is going to fail in any way. So we'd be looking at any kind of cracking that would be occurring along the crest or the top part of the dam. Also, sometimes if there's like a patch of real heavy or green vegetation along the side slope, that might be an indication that some water is seeping out in that area. Water level is important, particularly in a pond system where you have dams, and that the higher the water level, the more pressure there is on the wall of the dam. And there are like maximum design levels that are set by the engineers who construct the dam. And if the water level rises above those predicted normals or the maximum design elevation, then that can start causing problems with the integrity of the dam. So we typically look at staff gauges and compare those to the recommended operating levels.
Large facilities might require the presence of both an inspector and an engineer. This allows the team to evaluate the scenario together and discuss options.
Sometimes 2 people go out on inspection, so we can get a second opinion on any kind of observation that's being made. A lot of times in the field we'll discuss recommended corrective actions and that kind of thing, and it's best that 2 people see the same thing at the same time.
Photographs are a necessity for most inspections. Digital cameras make it easy to document the area and any potential problems.
A lot of facilities can change in the matter of a few days, so you can go back later and you don't see what you saw a few days before. Also, inspections document our problem if we have like an enforcement case. It can be used to support any kind of claims or alleged violations and that kind of thing.
Hillsborough County has 7 regional wastewater treatment plants. The Falkenberg Advanced Wastewater Treatment Plant is owned and operated by the county and permitted to process 6 million gallons a day. The county is looking to expand this facility. Professional engineer Ed Kopic joins Byron to make some engineering notes about the expansion. The treatment process is similar to the plant at Rice Creek, only on a much larger scale. Thousands of county residents depend on this plant to process their wastewater.
The raw sewage as it comes in is a sort of a dirty gray, maybe with a greenish tint, depending, for instance, on how much of an industrial contribution there is. In the aeration basin, it looks something like a thin chocolate mixture. That's one of the ways it's described in some of the literature. A healthy mixed liquor is described as a chocolate brown. Mixed liquor in the wastewater treatment process is the process where the aeration occurs, the bacteria are combined with raw sewage, and it's where the bacteria start the process of breaking down the sewage. When we're inspecting the aeration process, in this case the oxidation ditches, we're looking for evidence of areas where there may be insufficient mixing, insufficient aeration. We're looking at the color, the appearance, the quantity of the foam. All of those things are indicators of the health of the organisms and therefore the degree to which the plant might be capable of doing what it's designed to do. The third major step in the process is clarification. Effluent from the mixed liquor process, that chocolate brown, relatively thick liquid, goes into the clarifier where the turbulence occurring in aeration is allowed to be stilled. It becomes more quiescent, and then because the particles of agglomerating bacteria are slightly heavier than water, they will settle to the bottom fairly slowly, and leaving a clear water at the surface to overflow the weirs and go on to the next process. The filtration process removes particles, some of which may not even be visible to the eye, that are left in the clarification process. The reason for that is that bacteria can conceal themselves even in the particles that we can't see with the human eye. And as long as bacteria are present, there can also be pathogens present in the wastewater, such as viruses. The filtration process theoretically removes all of those. The last step in the process is disinfection or chlorination, and that's intended to kill off any remaining bacteria that were not removed by the filters. The aeration occurring at the influent end of the serpentine chlorination process is there at least partly to mix the chlorine with the wastewater coming in so that all of the wastewater is thoroughly exposed to chlorine, and then a thoroughly disinfected wastewater is sent out to reclaimed water users or is discharged to the surface water receiving basin.
The Purple Pipe Farm is used to do just that. It sends reclaimed water back out to the county, so residents can use it to water their lawns. Purple is the designated color for reclaimed water throughout the nation. Inspectors take note of any violations of the permit they might find. EPC does have the authority to issue a warning notice on the spot.
Our inspectors have some discretion on when they issue warning notices. Our warning notice, the way we use it in our agency, is a document that puts a person or a company on notice that we believe some violations have occurred, and we're going to prescribe some corrective actions.
And that's considered a violation. No discharge out of that lagoon is permitted except to the Sprayfield area.
No, I have been doing everything. Why you give me this?
And I would say most of our non-compliant situations that are dealt with in warning notices are complied with in a voluntary fashion and need not be escalated to enforcement. Once they've complied with our requirements, then the warning notice is closed and they continue about their business.
If a facility continually violates the conditions of their permit, the more stringent enforcement actions are brought into play. The most common of these is a consent order.
A consent order is just basically a document that outlines some facts about the case and then lays out a map of corrective actions and timelines to bring the facility back into compliance. Those are negotiated terms so that both sides are comfortable with the terms and the timelines. There's usually associated with a civil penalty for the violations and then a cost recovery for the agency.
Complaints from the community are also investigated by the EPC. Inquiries often originate from county residents, elected officials, utility companies, and even disgruntled employees of a company. Inspectors check up on each tip and find out if there is a basis to the complaint.
If it's a harassment complaint, there may not be anything to do. We go out, find out that there's really no basis to the complaint. That's the end of it, it gets closed out. The other end of that spectrum is if it's intentional discharge of something very harmful to the environment, we will go ahead and involve law enforcement and pursue action that way through them while simultaneously taking our own action through administrative enforcement processes.
A lot of people want to do the right thing, but there will always be others that want to circumvent. The rules were there to implement the program and allow everyone with such installation to be treated the same.
There will be no guesswork. There will be no assessment of what goes out by the facility itself. There should be a uniform application of the rules and uniform expectation of what goes out into the environment.
Besides permits and inspections, the Environmental Protection Commission has another asset to monitor pollution. In the heart of Ybor City resides the EPC laboratory. Scientists and lab technicians constantly test water and air samples from various points in the county. They are the first to know of a pollution concern in the Bay Area.
It gives us a general picture of the health of the water. People that use fertilizer don't really think about what happens once they apply it to their lawn. They want green lawns, but rain will come, it will wash it into the ditches and ultimately ends up in the bay. So you have your pesticides, PCBs, things like mechanics garages, everything we do on a daily basis is going to impact the environment in one way or another and ultimately ends up in our water and our soil. So it's really important, actually.
The EPC lab has two main sections: general analysis, which deals with bacteriology, BODs, and chlorophyll testing, and instrument analysis, which handles nutrients, metals, and organics testing. The process is very thorough and covers the full analysis of what is present in our air and water.
We do quite a bit. In the metal analysis, you can, like for Bentek, I do 14 elements. That's just for metals. And organics, we have a lot of organics too, compounds that we analyze for. And then we have the nutrients, which is ammonia, nitrates, nitrites, silica. Is quite a bit in operation that we have over here.
We monitor selected stations during the month to check if there has been any spills, runoff, or contamination in general. We don't want to have an overload of nutrients in any of the bodies of water because then you will have problems with algae and fish kills, so we keep an eye on them.
Wastewater treatment plants sometimes drain off to our bay waters. Before they drain, they are required to mix in oxygen to allow fish and plants to thrive. The lab verifies the oxygen amounts with their BOD test, or biochemical oxygen demand test.
And basically that is a type of test that tests the runoff from the waste treatment plants, municipal and industrial, to ensure that we have accurate oxygen for our streams and waterways. So of all the tests here, I believe it's one of the most tedious. It has so many steps, but it's very simple to do.
An initial reading is taken from the sample. Then, the scientist incubates the sample under specific conditions at 20 degrees Celsius for 5 days. Then, the oxygen is measured.
Basically what we're measuring is the activity of the microbial life, how much oxygen the bacteria is actually eating in order to survive.
Many of our sources for drinking water are tested regularly for bacteria. Human and animal feces present in the water can cause many health problems. Environmental scientist Nancy Roy keeps a watchful eye on any potential health hazard.
Fecal coliform and enterococcus is like an indicator organism to determine whether or not you have fecal contamination, like in the water. It's an indirect method of determining. You're assuming that if you have high fecal counts and enterococcus counts, that you'll have pathogenic bacteria and viruses also present.
Coliform is a family of bacteria found in soils, plants, and animals. One group in that family is the fecal coliform group, found in the intestinal tracts of animals and humans. The fecal coliform test determines the amount of bacteria and colonies present in the sample.
Basically what will happen is field inspectors will go out and they will collect a bacteria sample, which is for fecal coliform, bring that in. I will take a certain amount of sample and put it through a filter unit which contains a membrane filter. The fecal coliform bacteria will stay on the membrane filter. And I'll take that membrane filter and I'll put it on a petri dish that has MFC media. And then I will take that petri dish and put it in a water bath and incubate it for 24 hours. And then after 24 hours, I will take that out and I will look at it, and there'll be bacteria colonies or fecal coliform colonies, and I will count that. I use what they call a dissecting microscope to help count the colonies. You can see them through the naked eye, but it's difficult. Sometimes they're small.
Advances in technology have made the scientist's job much easier. Machines such as the ICP analyze the samples for metals, while the colorimeter checks for nutrients. Computer software automates the process of extracting samples. That's a long way from the days of getting your results by hand.
We had to mix them in flasks, and we get the reaction, the color produced, and then we had to read them in a spectrophotometer. Now the machines are so modern that you don't have to do all that manually. It saves a lot of time, so you increase your volume of samples that you can produce daily.
One of the more detailed procedures is testing for organics. Environmental scientist Kendra Cole prepares the sample for the actual testing done later.
Basically, when a sample comes in, we extract what will be PCBs and pesticides out of it. It's a polychlorinated biphenyl. Long time ago, they used to be put in like transformer oil and stuff like that. So they're bad for the environment.
The most difficult part is the actual extraction and cleaning process, which is done mostly by hand. But by the time the sample gets to me, I have equipment that's called gas chromatography. It's a procedure and a piece of equipment. We call it GC. And it's pretty much all automated. And the detector actually identifies what components and what pollutants are in the sample, as well as telling us how much of those pollutants are in the sample. So that's basically how the samples run, and then I use special software to analyze the samples.
Databases from these tests are sent to the permitting section. This checks and balances routine allows EPC to see if the results are meeting the compliance with the permit.
They work with that data to ensure that groundwater is being protected, maybe looking at groundwater monitoring data to ensure that the effluent is not impacting groundwater sources. All of this is to give us reasonable assurance that the day-to-day operation of the facility is meeting the permit.
The Water Management Division is continually updating the permitting process. Wastewater disposal methods that passed 10 years ago now meet additional scrutiny as more research is completed.
We as a society are evolved. The expectation of the citizens and the community of resource protection has evolved. And therefore, our understanding of protecting the environment and the technology for protecting the environment has evolved. Therefore, every 5 years we have an opportunity to go back and re-permit these facilities and improve on the permitting process in terms of having more controls of pollution, recycling, reuse. It gives us a chance to sit together with the regulated communities and look for ways to improve environmental protection.
The big plus within the water division is that we have a lot of people with years of experience, people that have been working here for in excess of 20 years.
That experience is evident year-round as the Water Management Division deals with keeping the environment safe for residents. Permits are granted, inspections are conducted, and water and air samples are tested. But the real satisfaction is summed up by 29-year veteran Nancy Roy.
Working in the environmental field, it feels like you're doing something good, that you're making our homes a safer place to live because we're monitoring the environment. You know, water is very important to all of us.
The next time you turn on the faucet in your home or flush the toilet, think about where that water came from and where it's going to. Our Water Management Division looks out for county residents every single day to make sure our waterways are clean. If you want more information about the EPC or our Water Division, check out our website at epchc.org or call us at 627-2600. I'm Rick Garrity, and thanks for watching Clean Living.